Hello. The next part we're going to explore is what happens when we divide expressions that have exponents. So we're going to go to very basic ideas here, something that you will remember very easily. Remember that a number divided by itself equals 1. So oftentimes we would just write things like this and say that these 7 cancels the 7 in the denominator and produces 1. We have to remember that this is not 0, but it's 1. So a number divided by itself is 1. So what is the connection between that and a question like this, where we have 7 exponent 4 divided by 7? And we know that 7 in the denominator is 7 exponent 1. Well, why don't we use our extended form or expanded form to write this? And if we do that, we recall that 7 exponent 4 is 7 times itself 4 times. And of course, the 7 in the denominator is just 1 time there. And of course, we can hopefully see that these two sevens cancel, and that produces really a 1. So at the end of these um, division, 7 divided by 7, we have 1 multiplied by 7 times 7 times 7, which really is 7 cubed. And if we were to evaluate that, we arrive at 343. 7 times 7 is 49, times 7 is 343. We can express a similar question using the division symbol like this. And the exercise is very similar. We are dividing 3 exponent 5 by 3 squared. And this is equivalent to 3, if we do it in expanded form, 3 multiplied by itself 5 times in the numerator, or the dividend, and 3 multiplied by itself 1 time in the denominator, or the dividend divisor, excuse me. And so now we can see that we can cancel 1 time, 2 times those threes, and the effect of that cancellation is the number 1. 3 divided by 3 is 1, multiplied by 3 divided by 3, which is 1, and at the end we end up with 3 multiplied by 3 3 times, which is 3 cubed, equivalent to 27. 3 times 3 is 9, times 3 is 27. So now we're going to go and do an exercise similar to what we did during the first part of the power rule.